Hello students, in the last video we have discussed PDA definition, tuple notation and the operations. So now we'll discuss how to construct the PDA for some examples, right? For some languages. Sorry. Let me go with this. So this we have already discussed the language, but let me write it once again. So what is the language denoted by this? Epsilon. Number of A's must be equivalent to number of B's, A, B, B. Right. So triple A, triple B. First of all, whether it is regular language or not means no. Why? Because we have a dependency, guys. Whenever there is a dependency between the variables, for example, if I take 3A's or 4A's, how many B's I can take? If you are allowed to take any number of B's irrespective of the A, then I can say that it is regular. But here, the number of B's must be equivalent to the number of A's. So there is a dependency between, okay, there is a dependency between A and B, right? A and B. So this dependency, if you could able to do it with a stack, right, which is initially having Z0, then we can say that that is context-free language or push down. It is accepted by push down automata. How can we do that? So guys, we are having any language you are given that must be recognized with the three operations: push, pop, and no push, no pop, or no operation simply. Okay, no push, no pop operation. When we have to perform push, listen here please. See here we are having two variables x and y. If x is depending on y or y is depending on x, whatever it is. If both variable are in dependency, if x is the first variable in the dependency, while it is coming, if it is the first, then this we have to push into the stack. If two variables are involved in the dependency, if x is first in the reading, while you are reading the input string, if x is occurring first, that you have to push. You have to push it for what? Y. So push all the occurrences of x into the stack. Push x. So we have x in the stack. And when you read the y, this is a second variable in the dependency. For this y, whatever the dependent variable, we have already pushed into the stack. For this y, you have to pop whatever you have pushed. So you have to pop x only. Because what you have remembered for this y, x you have remembered, that is in the stack, then you have to pop that. Whatever you have pushed for y, that we have to pop out. And assume that we have a variable which is not involved in the dependency, right? Not involved in the dependency, then you no need to perform any operation, right? Let me explain this. Here A. See A, check it. Is it in the dependency or not? Yes, number of A's must be equivalent to number of B's. So for the first A, what is the top of the stack? Z0. Then again you have to push it because A is involved in the dependency. Now the top of the stack is A. For the second A, push it. For the third A, push it. For the fourth A, push it. All the A's you have to push. For the B, yes, this is a second variable. All these should be pushed. Then for this B, we have to pop whatever you have remembered earlier, A. For every B, pop 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 A. Then if there is no symbol and the top of the stack contain no A's or Z0 initial, then we can say that number of A's are equivalent to number of B's. Right? Then how to draw the PDA? Let me go with this, guys. How to draw it? See, first let me take current state, the input symbol, top of the stack, next state, operation. Once we have done it, then I'll tell you how to write it. Okay. So if the current state, I'm starting with the Q0, what are the input symbols possible? A, B and epsilon. That's it. Nothing more than that. Okay, input symbol A, B, epsilon. So if the input symbol is A, what are the possibilities on top of the stack? For the first A, we are having Z0. For the remaining all the A's, we are having A. That's it. For any A, first A, Z0, for remaining A's, A only. So only one possibility. Right? Either Z0 or A. So I'm not changing the state here. I'm not changing the state here. Why? I'll tell you later. Then what is the operation we are performing? Push. Right. Then for Q0, if the input symbol is B, what is the top of the stack? Must be only A. Because for every B, we must have the A, right? A, then which operation we have to perform? Pop. But here I am changing the state to Q1. Why? If you will be in the same state after the B also, then after A you can take the B, after B you can take the A. That is not allowed. So after B you are not supposed to take the A's. That's the reason I am changing the state. If you are allowed to take A's after B, B's after A, no problem. So BA pop. Like how many times I can take this BA? Any number of times. That's why you write one more time. So BA pop. I'll tell you this once again with the diagram. Okay, pop. Then on Q1, if there is no symbol on the stack or input symbol, then the stack also must not contain no symbol. So if it is epsilon must be Z0, then you can accept it by going to the final state. This is the possibilities. Draw the diagram. You can do it easily. Listen here if you are not understanding. So first, let me go with the Q0. Q0, current state, where we are going? Q0 only. You can take it. So Q0, when if the input symbol is A, what is the top of the stack? Z0. What is the operation we are performing? Push. Push means I told you now, you have to write A Z0. This is how we are going to do. Then AA, same. Q0, again where we are going? Q0 only. Self loop you take one more time. When, if the input symbol is A, what is the top of the stack? A. Which operation you are performing? Push. Then you have to push this A into the top of the stack. Then B, Q0, where we are going? Q1. See this guys, why I am taking it. I'll tell you now why I have taken one more time. The input symbol is B, we are going to Q1, right? When the top of the stack is A, which operation we are performing? Pop. See how many B's are possible in our language? Any number. But if I write like this, how many times I can take the self loop? Any number. But how many times I can take this edge? Only one. But only one B is allowed in the language. Only one B, no, right? We are having any number. That's the reason I'm repeating the same step one more time. B, A, epsilon. So that you can take any number of B's. But why I didn't take here? If I be in the same state for the B, after B again I can take A. That is not allowed. After A, you are not supposed to take the B again. Sorry, after B, you are not supposed to take the A again. So epsilon Z0, you can simply accept it by going to the final state. So this is the PDA, guys. That's it. So we'll get it. So here the epsilon is treated as lambda. And see, they have mentioned both self loops, one only. Okay, going on, you can take it, no issues. But so epsilon Z, we can remove it. Okay, or you can go to final state to accept it. These two we'll discuss what is that. Okay, then let me go with this. See here, the number of A's are equivalent to number of C's, but B's can be taken any number. Let me go with this, guys. What is this language? A and C should be equal, B no need. Means if I take 3 A's, how many B's I can take? I can take any number of B's, no restriction. But how many C's? I must take 3 C's. So now you have to do like this. So initially Z0 for the first A. Which variables are in dependency? A and C. So A has to be pushed. This we have to push. Is B is involved in the dependency? No. Then no push, no pop. Because B is not involved in the dependency. C, yes. With which variable? A. So for the C, you have to pop A. Because for the C, we have remembered the A, right? Then we have to pop A only. For every A, push it. For 3 A's. For B, no push, no pop. Because don't pop anything, don't push anything. Because it is not involved in the comparison. And for every C, pop A. For every C, pop A. For every C, pop A. Epsilon Z0 you can. And how to do the PDA, guys. No need to write every time like that. Q0. So first one, for the first A, you are going to have the Z0. You push it simply. For the second A, you are going to have the A. Push it. For the third A, push it. Fourth A, push it. Like that, you can take any number of times as it is a self loop. Then, if it is B, take the next state because we should not allow to take A's again. So B, the top of the stack is what? A. Then no push, no pop. Same thing. BA, no push, no pop. like, but how many B's are occurred? Any number of B. That's why you take self loop one more time. So BA, no push, no pop. Then after B, you'll be having C. For the C, what must be the top of the stack? A, perform pop, because for C must be A. Then like for any number of C's, you can take pop. Okay, then you can write epsilon z0. You can accept it by going to the final state. So this is how we have to draw it. See, same. Okay. Then let me go with another example called WCWR. What does it mean? WR is the reverse of W with anything. For example, you can take the language like this: C, AC, A, B, C, B. Whatever you have taken before C must be reverse. A, B, C, B, A, or B, A, C, A, B, or A, B, B, C, B, B, A, so on, like that. So which is dependent here? Whatever we have taken before C, you can take whatever you want. Like I'll take A, B, 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 A, something. But after C, you can't take your wish, right? You must take the reverse of it. So you have to take A, B, B, A. So what you have to remember, before C, whatever you have taken, that we have to push it. After C, if both are same, then only you have to pop it. Both must be same, right? If both must be same, then only it is WWR. Otherwise, it is not in WWR, like that. Then how to construct it? Guys, listen here now. For the first A, right? For this, you have to push everything until C, right? For the first A, what is a Z0 A? Push it. For the second A, push it. For the B, A, push it. For the B, B, push it. For the B, B, push it. For the A, B, push it. Everything. For the C, no push, no pop. After that, A pop, B pop, B pop, B pop, A pop, A. So before C, okay. So if it is C, you may be having A, no need to push anything. If it is C, sometimes you may have B, no need to push or pop. If it is C, sometimes you may have Z0, no push, no pop. Like C. For this C, we will be already having the AB in the stack. For C, B. For this C, we will be having A. For this C, we will be having Z0, like that. No push, no pop. But before C, if it is A, what is the top of the stack? Sometimes it is Z0, then push it. Sometimes it is A, push it. Sometimes it is even B, push it before C. See, for the last year, what is the top of the stack? B. You have to push everything. Same way for B also. For the first B here, A, you can push, right? For the second B, B, you can push. Now, why I taken the same state again? After B, I can take A. After A, I can take B. You can take whatever you want. That's the reason we are doing it. Then for sometimes for B, we may have Z0. Again, you have to push it. For example, if the string is starting with the B, then the stack is initially having Z0. You have to push it. Then after C, if the input symbol is A, the top of the stack must be A. After C, Q1. If the input symbol is B, top of the stack must be B. Then you have to perform. Otherwise, the language is not accepted. You do like that. At the end, if both are empty, then we can say that it is accepted. So this is how we are going to construct. See, same thing you can see here. I hope you got it. Otherwise, you do take some strings and you cross verify it. Like that, you can construct any number of PDAs. Of course, we'll be having different kinds of PDAs that we'll discuss in the next videos also. What are the languages accepted by the PDA? In how many ways we can accept it? We have such examples also. We'll discuss that in the next videos.